Hello everyone. So in previous video session, we have seen how we can find alkalinity of water sample in laboratory, and also we have learned what exactly alkalinity of water sample is and which are the salts responsible for it. So in today's session, we are going to solve a numerical for finding alkalinity of water sample. So this is the question that 50 ml of water sample requires 9.2 ml of N by 50 HCl up to phenolphthalein endpoint and total 13.1 ml of acid for complete neutralization. So we have to find the types as well as amount of alkalinity present in water sample. So let us first note down what all is given here. So we have been given that the volume of water sample is 50 ml and we will take it as capital V. Then volume of up to phenolphthalein endpoint. It is given as 9.2 ml. Phenolphthalein endpoint means for phenolphthalein to change its color from pink to colorless. So initially we are adding phenolphthalein as an indicator, and for phenolphthalein to change its color from pink to colorless we require 9.2 ml of acid, which we have taken as V1. Then the concentration of HCl is given, which is N by 50. So N is the unit of normality. So concentration of HCl is in normality. N is the unit for it. So it is N by 50 means it is 1 by 50 normal. So 1 by 50 is 0.02 normal, which is the concentration of HCl. Further, it is given that for methyl orange endpoint. So we know in this alkalinity experiment, we use two indicators. One is phenolphthalein, another is methyl orange. After the phenolphthalein changes its color from pink to colorless, we add methyl orange into it. And when methyl orange is added, it changes its color from yellow to orange. So here it is given that 9.2 ml of N by 50 HCl is required up to phenolphthalein endpoint, and total 13.1 ml of acid is required for complete neutralization. So this total which is given, it is for the methyl orange endpoint, because once phenolphthalein changes its color, we add methyl orange indicator. So this total would be taken for methyl orange endpoint, which is V2. It is equal to 13.1 ml. So we know the formula that for calculating phenolphthalein endpoint, denoted by capital P, it is equal to V1, that is the ml of acid required, into N, which is normality of acid, into 50 into 1000 divided by capital V. So capital V is the volume of water sample. Once we put the values in this formula, we will get the answer for phenolphthalein endpoint, capital P, which is 184 ppm of calcium carbonate equivalent. So this is the unit of alkalinity. Similarly, we'll calculate the value of M, that is methyl orange endpoint. The formula is V2 into N into 50 into 1000 upon capital V. So all the things are same except for methyl orange we are going to take V2, that is the total amount of acid required for complete titration, which is 13.1 ml. So we will substitute the values and we will get the value of capital M, that is methyl orange endpoint, as 262 ppm of calcium carbonate equivalent. So we have got the value of P and we have got the value of M. Now we need to find the types and the amount of alkalinity present in water sample. So we know that alkalinity in water sample are of 5 types. Okay, so it can be only hydroxide, only carbonate, only bicarbonate, or the combination of two. That is combination of hydroxide and carbonate or combination of hydroxide and bicarbonate. So one type is not possible, which we had seen in the previous session. So let's see further. So we have the value of P, which is 184 ppm of calcium carbonate equivalent. We have the value of M, which is 262 ppm of calcium carbonate equivalent. Now we will refer this table. Okay, so you need to learn this table. So if the value of P is 0, then the type of alkalinity would be only bicarbonate, because you can see here hydroxide is 0, carbonate is 0, and only bicarbonate would be present, and the value of that alkalinity would be equal to value of M. So we don't have the value of P as 0. So this does not match. Okay. Let us see second, if P is equal to half M. So we have the value of P as 184, and half of M means half of 262 would be 131. So 184 is not equal to 131. So this second criteria is also not satisfied for us. Is the value of P equal to M? So we can see the value of P is 184 while M is 262. These two are not same. So this criteria also does not match. Is the value of P less than half M? So is 184 less than 131? Half of M is 131. So 184 is not less than 131. So this also does not match. Is the value of P greater than half M? So yes, 184 is greater than 131. So this criteria matches. So we'll look here in the table that our value of P is greater than half M. Okay, so what is present? Hydroxide is present as well as carbonate is present, while bicarbonate it is given as 0. So bicarbonate is absent. So type of alkalinity would be hydroxide and bicarbonate. Sorry, here it should be hydroxide and carbonate alkalinity, not bicarbonate alkalinity. Here it would be hydroxide and carbonate alkalinity because bicarbonate is absent. So we have to calculate the amount of hydroxide and carbonate alkalinity. So amount of hydroxide alkalinity would be, we have to calculate. So the formula is 2 into P minus M. So you will just substitute the values and you will get the amount of hydroxide alkalinity as 106 ppm of calcium carbonate equivalent. Similarly, for carbonate alkalinity, the formula is 2 in bracket M minus P. So you will substitute the values and you will get the amount of carbonate alkalinity is 39 ppm of calcium carbonate equivalent. So now we have found the type of alkalinity is hydroxide and carbonate alkalinity, and the amounts are 106 and 39 ppm of calcium carbonate equivalent respectively. Okay, so this is how this numerical is solved. For this, you actually need to remember this table. There are few practice questions given ahead. So these are some problems for practice. You can solve it by the same formula and by referring the table given. So here is one thing which you need to pay attention to. Like, let's look at the first question, that here it is given that 100 ml of water sample required 4 ml of N by 20 H2SO4 for neutralization. So capital V in this is 100 ml. Okay, it required 4 ml of N by 20 H2SO4 for neutralization to phenolphthalein endpoint. So V1 in this case would be 4 ml. Normality of acid is N by 20. Normal means 1 by 20 normal. So 1 by 20 normal you have to calculate and you will get the normality of acid. Then it is given another 16 ml of the same acid was needed to methyl orange endpoint, and we have to determine the types and amount of alkalinity. So here you have to pay attention to the word another. That means first you required 4 ml of acid for phenolphthalein endpoint, which we have taken as V1. But for V2, they have said another 16 ml was required. Means V2 would be 16 plus 4. So the amount or the value of V2 would be actually 20, because V2 for methyl orange endpoint, we take the amount of acid which is required for complete neutralization. So you have to pay attention to these words. Like in the second numerical, they have given that 50 ml of water sample required 8 ml of N by 50 H2SO4 for neutralization to phenolphthalein endpoint. So here V1 would be 8 ml, and then it is given, and total 20 ml of the same acid was needed for methyl orange endpoint. So in this case, the word total is used. So V2 would be directly the value of 20 because total they have given. While in the first question they had said another 16 ml was added. So we have to add 16 plus 4. So these things you need to pay attention to. Once also here in the third example, it is given that 100 ml of water sample was not alkaline to phenolphthalein. That means it did not show a color change when phenolphthalein was added. That means phenolphthalein, the value of P would be 0. Why it would be 0? Because 100 ml of water sample was not alkaline to phenolphthalein, means it did not change its color, so no acid was required. So V1 would be 0, and if V1 is 0, that is why P would be 0. And then it is given that 10 ml of N by 50 acid was required for methyl orange endpoint. So capital V is 100 volume of water sample. 10 ml given here is actually V2, which is required for methyl orange. Concentration of acid you can calculate from this, and you can substitute the value. So this would match the first criteria of the table, where value of P is equal to 0. So you can try and solve this numericals. The formula is given and you can refer the table. That's all for today. Thank you.